Hello everyone, welcome back to the Quiz Solutions videos. This will be the Quiz Solutions video for Quiz 12. It will be the very last video that I make for you guys. It's very sad and bittersweet, but I'm very proud of you all for getting this far. We're almost done, so hang in there, right? It's been a wild ride. So let's go ahead and get started. This will be Quiz 12. And then the very first question, right? What are the major products for the reaction shown below? This is a run-of-the-mill hydro halogenation, and so in a hydrohalogenation we get Markov addition of the nucleophile, and we also get it in 50-50 amounts, right? So it's a racemic mixture, and so the Markov addition would be 1 and 3 racemic amounts of both R and S, right? But then we also get structure 4 as well, because we can easily do a carbocation rearrangement here, where when the alkene comes and deprotonates the hydrogen bromide, right, we end up with a carbocation down here. But then a rearrangement can occur where the hydride shifts that way to that carbocation, leaving you with this guy right here, right? Actually, that looks pretty bad. Let me draw that again. Leaving you with this guy right here. And now the carbocation is there, right? And now the bromide ion can easily do a nucleophilic attack there, leaving you with structure 4. So remember what I said in lecture. If a carbocation rearrangement can occur or will occur, and there it goes. Next. What is the best reagent for the reaction shown? So this is, you can see here, this is actually an anti-Markov addition right here. Right? And since it's an anti-Markov addition, the only way you can do that is by doing it with some HBr and some peroxide. Right? Some HBr and peroxide. Just a little bit, right? Remember, trace amounts where we're able to achieve the anti-Markov product. Next question. Select the best reagents for the reaction below. So here we actually have an allylic bromination. Allylic bromination. And then when you have an allylic bromination, really the only way to do that is to have some light and some NBS. Right? Some light and some NBS. Recall that this is actually a radical reaction that occurs to get an allylic bromination, right? And to do that, we have some, again, UV light and NBS will do that for you for allylic bromination. Next, what is the best reagent for the reaction shown here? We have anti-addition in the halogenation here. So this is a halogenation, regular old halogenation, which also always results in an anti-addition. Right, and so to do that, we would use bromine gas in carbon tetrachloride. Next, oops, went too far. Can't read the question. There it goes. Select the best reagents for the one below. Select the best reagents for the reaction below. This is the halohydrin formation. Right, and in the halohydrin formation, we always have to use bromine and water, right? Makes sense, right? We have the OH there and the bromine there, and it's an enantiomer, of course. Select the best reagents for the reaction below. Here we have a ZZEV product. ZZEV. I never know how to spell ZZEV. Whatever. We have a ZZEV product, right? From an elimination reaction. So to do a ZZEV product in an elimination reaction, we have to use a very slender base. The slenderest base there is going to be sodium hydroxide, right? Quite simply, sodium hydroxide can deprotonate this proton right here, and then this bond comes down, and then we lose the bromine, and we get our ZZ product, right? Next, we have our Hoffman product. So it's the opposite of the previous question, right? Now we want to have a Hoffman product, so we need a bulky base. The only bulky base here is sodium terpbutoxide. Okay. So this is our Hoffman product, as opposed to the question previously, that was a ZZ product. Okay. So using DBU, we actually also get a Hoffman product. We can Hoffman I don't know what that's about. Maybe I was trying to write out product and I just forgot to finish writing it out. Hoffman, there we go, product. And so DBU can actually accomplish an elimination, right? And then you'll get a Hoffman product. And so the answer there would be D. It's the only one with a Hoffman product. I don't know why there's an extra carbon here, so that's why that one's wrong. This one has a double bond in the wrong place, and DBU does not act as a substitution product. So it's definitely 4, structure 4. Okay. Next, select the best reagents for the following reactions shown below. This is going to be the ozonolysis of a this is the ozonolysis of a alkyne, and when we do that, we always get a carboxylic acid where we used to have the triple bond, right? So the triple bond splits back down right there, and that's how we get this product here. So the only one that has ozonolysis going on is going to be D. Answer there is D. Next, and is it the last question? That's actually the last question. Perform a retrosynthetic analysis by working backwards in the steps in the given synthesis. Identify the possible combinations of A and B to lead to compound C, right? Well, we already know that when we have a syn addition of alcohols like that, the way to accomplish that is to use osmium tetroxide, right? And the way we use osmium tetroxide, what we use with osmium tetroxide to get syn addition is an alkene, right? So structure B will be this, right? It's going to be that alkene, and then there won't be any more stereochemistry because these are all sp2 now, okay? And then the question then is, how do we get that alkene to begin with? Well, we can easily get that alkene by eliminating a halogen, right? From the position where the alkene needs to be. Right? And so to do that elimination, all we need is sodium hydroxide. So let's go down here to the answer choices and see what we have. So the first thing we want to see is for B, we want to find this structure right here. Okay. So that's in the wrong place. That double bond's in the wrong place. That's missing a carbon. That's missing a carbon. So V. Whoa, that was crazy. Undo. So V. Whoa, what is happening here? Maybe I should just scroll down a little further. V, there we go. That's what was going on. And then we need our next structure here, which is going to be the cyclopentane with the bromine substituent next to the ethyl group, right? And that's going to be structure 2. So let's see here. We want B to be structure 5, and then A to be structure 2. Ah, here we are. B equals 5, A equals 2. Okay. Good stuff. Good stuff. I just flipped it upside down from here to here. by the way. Okay, I just flipped it upside down. Anyway, that will be the end of our quiz solutions video.